Good morning, everyone. So this video gonna show you the general solving process for a linear programming problem. And even though we have mentioned, I think many times, and we have practiced several case problems, I think I need to, emphasize on this part because it's, very important, especially for the beginners. So basically, let's do a quick review. So we all know, so in order to solve a linear programming problem, so first we need to, establish the model. Establish the model. And the second step, and we want to put the model into Excel. And the last step, we want to put the module add into the solver. So then we can click on solve, and the Excel computer gonna give us the results. So however, so these two parts are not that important. So maybe you find some difficulties, in converting into the Excel format or add to the solver, but actually that's not the significant part. The most important thing is the first one, establish the module. And so we already know a module have two elements. The first one we called objective function. And the second part we called constraints, or WST, the subject to. So that's the two parts. So basically in the objective function, right, remember, so from the simplest objective function where we want to maximize or minimize, maximize the profit or minimize the cost. So basically there are two types of the object functions. And regarding the constraints, right, the constraints part is a little bit complex because for different scenarios, we can have, various constraints. But the key thing is, well, how can we determine so which one is, which value belongs to the object function, and how can we determine if it is the constraint? So let's take the example of the first problem in homework 4. Maybe I can copy and paste. I'm gonna copy the whole thing and paste it to our not bad. Okay, so for this example, so basically we got a lot of information, and we see, so many numbers. 0.60, 0.85, 30, 60, 5,000, 4,000. No, we can lost in this huge amount of information. But here is one, small tip for you to more effectively to determine which value should belong to the objective function and which value belong to the constraints. So basically, there is a tip. So basically, if a value is not subject to change. So basically means that is a coefficient. Also, oops. So if a value is subject to change, so usually, not always, but usually, that's the decision variable. So basically, in this problem, because so let's read through all the paragraphs. So White Horse Company. So White Horse Company, they purchased Apple and making two kinds of products, so applesauce and apple juice. Right? It costs 60 cents to produce a jar of applesauce and 85 cents to produce a bottle of apple juice. All right. So these two values, they are not subject to change. So no matter how many bottles or how many jars you produce, for sauce or juice, these two values won't change, right? So that's the coefficients. So we should highlight that for further use, right? We should highlight this too. Okay, so continue reading this. So the company has a policy that at least 30%, but not more than 60% of its output must be applesauce, right? So when you see, like the boundary thing, so like the upper limit, lower limit, or give you some interval. So usually you should think about, okay, could it be a constraint, right? And in this case, because so it's saying like at least 30, no more than 40, 60. So that's one constraint for what? For the applesauce amount or applesauce percentage over the total produced products. So basically, so far we found two decision variables and two coefficients, right? So if we use x1 to represent the jars of applesauce, and we use x2 to represent the number of bottles. Maybe I should put the number. So number of jars, number of bottles of apple juice. So that's the decision variable, right? And we also found one constraint. So we also want to highlight that. So maybe with a different color. So that's the constraint. Okay, so continue reading through this. Maybe that's too large. Okay. So that's the first paragraph. And we know two decision variables, two coefficients, and maybe two constraints. So the second paragraph, so that company wants to meet but not exceed the demand for each product. Right, so you can have a shortage, which so not exceed the demand. So basically, if the market requires maybe 5,000, right, you can produce 4,000, but you don't want to exceed the demand, so you cannot produce maybe 5,500, not exceed. So that's another constraint, because it tells you, the upper limit for the product quantity. Okay, the marketing manager estimates that the demand for applesauce is the maximum of 5,000 jars. So that's 5,000, another number. And plus an additional 3 jars for each dollar spent on advertising. So basically, this sentences tell us if you spend $1 on advertising the applesauce, right? You can sell three more jars. So if we see we spend only $1 for advertising of the applesauce, we can sell, or we can expect a demand of 5,003 jars. So that's another formula. And for the second one, so the maximum demand for apple juice is estimated to be 4,000 bottles, plus an additional 5 bottles for every $1 spent to promote apple juice. Oops. So when you see the, say the values, so always think about that. So can we change that? So for the 5,000, is there any way we can change that? So think about that. And for the 3 jars, can we change the number 3? And for each dollar spent on advertising, so can we change the money spent on advertising? Yes, we can. So that's another decision variable. So I'm gonna put it over here. So X3, so gonna be the amount of money spent on advertising of what? Of apple sauce. And X4 gonna be the amount of money spent on advertising of apple juice. So far we have 4 decision variables. And so that's basically telling us, so what's the demand for the apple juice and for the apple, I think where is it? So applesauce. And we keep reading this. So the company has $16,000 to spend on producing and advertising applesauce and apple juice, right? So that's your another limit. So the money, you only have $16,000, right? And you should design, the production and advertising for the applesauce and apple juice. So that's our decision variables. Oops. So basically, we need to find the answer. How many bottles, how many jars we want to produce. So that's X1, X2. And advertising applesauce, apple juice, that's X4 and X3. So the money spent on advertising applesauce and apple juice. So lastly, so applesauce sells for 1.45 per jar. So that's the selling price. And the company wants to know, so how many units of each product to be produced and how much advertising to spend on each to maximize profit. All right. So basically, through these 2 paragraphs, we know 4 changeable things. The first is the number of jars of apple sauce, and second, the quantity of apple juice. So third, number 3 decision variables is the money spent on advertising of applesauce, and the last decision variable is the money spent on advertising of apple juice. Right. So how can we get that? So keep these 2. Auto highlight. Maybe a deeper one. Okay, so always keep in mind when you read the problem, think about if a value is not subject to change, so that's the coefficients. And if a value is subject to change, right, basically means we can change that. And if we can change that, so that's the concept of operations management, right? We can manage how many pieces, how much money we want to spend on advertising. So where we can do the management annually, that's the decision variables. Okay, so that's the first step. So the first step, you read through the problem, you want to identify how many decision variables are there. And in this problem, so we got 4 decision variables. Okay, so next step, right? So, and also ask that question. We want to formulate the module, linear programming module. Okay. So how to formulate a module? And basically we follow our standard module. So basically in the module, we need to formulate the equation of object function and all the constraints. So starting from the object function. So basically, we can get 2 types, in the operations management field. So either maximize the profit or minimize the cost. So basically, this problem asks about maximize the profit. So it starts with one simple thing. So objective function. So what's the profit formula? So remember from the very beginning of this course, we learned this formula. So profit equals to revenue minus the total cost. All right, remember that. So profit, revenue minus total cost. So in this problem, so we use Z to replace profit. What's the revenue? So revenue gonna be the only source of revenue is come from selling products. So that's you sell the applesauce, you got $1.50 per jar. That's your revenue. Plus, if you sell the apple juice, you can get 1.75, right, times the quantity. So that's the total revenue for this problem. So what's the cost? Right. So if you run the manufacturing for your cost of materials, cost of labor, cost of equipment, but in this problem, it simplify the resources. So basically, it tells you if you want to produce 1 unit of jar of applesauce, it costs you 60 cents. So that's your unit cost. And 85 cents is the cost for what? For each bottle of apple juice. Right. So that's the production cost. Or like we can see equals to revenue minus total production cost minus total advertising cost. All right, so that's the revenue, that's the total production cost, and we only need to subtract the advertising cost. So advertising cost determined by X3 and X4. So that's our objective function. We're starting from, from the very simple formula. So basically, you need to find all the related information, but you'll have to put that into this formula because profit equals to revenue minus the total cost, right? So this formula is valid. It's valid through all the problems. So you need to keep that in mind. But there might be subterms, so in the cost or in the revenue, right? So in that case, you need to find that information based on the given information. Okay, so in this problem, we got only one source of revenue, but two sources of costs. So basically, we put the revenue over here, and we put the total production cost and the total advertisement cost. Okay, and don't forget to simplify everything when it is possible. So basically, we got two terms involved with X1. All right, so basically, we're gonna simplify that times X1 plus 190 times X2 minus X3 and minus X4. So that's our final objective function. So that's our final object function. Also, so the second part is gonna be, the constraints. That's the first step. The second step, you have to determine the constraints. Okay, so let's talk about all the constraints. We need to read the problem one more time. So the White House, purchased the sauce juice. That's the cost information. Right? We have used that information, and the company has a policy that at least 30%, but no more than 60% of output must be applesauce. So what's the total output? The total output gonna be X1 plus X2, right? Because it only sells these two products. And the ratio of applesauce, so that's X1 over X1 plus X2. So the ratio should be at least, right, at least 30%, but no more than 60%. So that's our first constraint. Okay, so that's our first constraint. So basically, or you can like divide into two, so it doesn't matter. So that's the first one. Copy and paste. That's the first. That's the second. Oops. So that's the second. But remember, we have discussed this last week. All right. So when you when you starting to solve this problem, right, you're gonna see an arrow because at the very beginning, x1, x2 are set to be 0, and you got this div arrow, right? So you need to simplify this term. You need to simplify that, and then we have to go over that. So I will skip that part. You need to simplify the term. And if you keep reading the problem. So wants to meet not exceed demand for each product, right? So what's the demand? So we have given the x1 as the total produced, but what's the demand for applesauce? Right, so that's gonna be our third constraint. Third constraint. So basically, okay, so that's our third constraint. So basically means the quantity we produced cannot, right, exceed the demand. So what's the demand for applesauce? So the following sentence is telling us, so no, the manager expects 5,000 jars plus, if we spend $1 on advertising, we can sell 3 more jars, right? So that's the baseline, 5,000 plus 3 times what? 3 times the money we spend on advertising applesauce. And the amount of money is represented by x3. So that's the third constraint. And we keep doing that. We got the fourth one. The fourth is about the apple juice. So the same thing. So the quantity we produced of apple juice cannot exceed the baseline plus the additional demands that because of advertising. So in this case, that's 5 bottles, so times 5 times x4. Okay, so that's the fourth constraint. And keep reading this. So the company has $16,000 to spend producing and advertising applesauce and apple juice. All right, so you have limited budgets. You have limited budget. The fifth constraint gonna be spend on producing, advertising. So what's the cost? What's the cost? All right, your upper bound of budget is $16,000. So which means the total money you can spend on producing, advertising cannot exceed that. And so what's the formula of your total cost? All right, so remember that's the total production cost, total advertisement cost. Right. So we copy paste. And remember, so 60 cents for each applesauce plus 85 cents for each apple juice, plus the money we spend on advertisement of applesauce, plus the money we spend on advertisement of apple juice. So the summation, that's our total cost. The total cost cannot exceed $16,000. So that's the fifth constraint. And do we miss any information? To double check. The company wants to know how many units, how much money we spend on advertisement. Okay, so basically, all the information given in the problem that we used to formulate our module. So that's our module. That's our module. And that's the OBJ. So as your final module, right? So that's the solving procedures, but we don't need that. So basically, in the module, we have one objective function. We got 5 constraints. So next step, we're gonna put that information. Right, remember to establish the model. So we got the model. We got the model. And always keep in mind, so when you see a value, try to change that. You find, okay, so this value I cannot change. That's going to be your coefficients. And you find, okay, so I can change that, right? Or actually, so that's your decision variables. And you should use that as your decision variables. And so that's the first step. We have got our module. I've got our module. And actually, we should put six constraint. So x1, x2, x3, x4 shall all be greater or equal to 0. Right, so that's the complete module. So the first step, we have established the module, and second step, we put the module into Excel. So basically, let me open Excel file. Okay, so once you got this module, the next steps, not that easy, but not difficult anymore. Not difficult anymore. So basically, when you got your module, remember we start with the object functions. Oh, sorry. We start with identifying the decision variables, and we put the formula of object functions and constraints. So that's part of the module. But firstly, the same thing, we want to put the decision variables, and we put the objective function, and we put our first constraint, second constraint. Well, maybe I should use the lowercase. So first constraint, second constraint, the third, fourth, fifth, and sixth. Okay. So we use the B1 through B4 to represent X1 through X4 in Excel. And for the object function, so we just put 0.85 times X1. So remember, so here we don't put X1 because Excel won't recognize as X1. So we need to put B1. Now use the Excel language. Plus 0.90 times X2 minus X3 minus X4. So that's our object function. And you found 0, right? Because by default, if you don't have a value for these 4 cells, by default, that's 0. So you got a 0. That's totally fine. And for the first constraint, right? So remember in the formula, we got x1 over x1 plus x2. So this ratio should be greater or equal to 30%, right? But actually, remember we need to simplify this term. So how to simplify that? So basically, yeah, maybe I should start with a new page. Okay, over here. Okay, so the first step, 0.3, color. So 0.3 less than or equal to x1 over x1 plus x2. All right. So if we multiply x1 plus x2 on both sides, we got 0.3 times x1 plus 0.3 times x2 should be less than or equal to x1. And if we move all the term to the right side, we got 0 should be less than or equal to x1 minus 0.3 x1 minus 0.3 times x2, right? And simplifying that, we got 0.7 times x1 minus 0.3 times x2 should be greater or equal to 0, right? So we put that simplified formula over here. So 0.7 times x1 minus 0.3 times x2. So this value should be greater or equal to 0. Right. And for the second constraint, that's the same thing. So basically, we got. Maybe let me demo that one more time. Okay, the same thing, multiply on both sides. So x1, oops. So x1 gonna be less than or equal to 0.6 times x1 plus 0.6 times x2. And move to everything to the right side, to the left side this time. So x1 minus 0.6 x1 minus 0.6 x2 should be less than or equal to 0, right? So that's 0.4 times x1 minus 0.6 times x2 should be less than or equal to 0. Right, so we put that formula as our second constraint. So 0.4 times x1 minus 0.6 times x2. Right, so this value should be less than or equal to 0. Less than or equal to 0. So regarding the third constraint, same thing. Always try to simplify until one side, either left side or right side only have the values, excludes the different variables. So for the third constraint, we will do move everything to the left. So that's going to be x1 minus 3 times x3. And this value should be less than or equal to 5,000. So same thing for the first one. So the first, we got x2 minus 5 times x4. Right. So this value should be less than or equals to 4,000. And we got one more, the fifth. So equals to 0.6 times x1 times x1 plus 0.85 times x2 plus x3 plus x4. So the summation of the cost should be less than or equal to 16,000. So the last constraint is the one general one, non-negativity. So we're gonna So we're gonna put that information in the solver. So double check. So we got our different variables, or or you can see the variables. Okay, the stick out border, or we can just highlight everything and give all borders. So that's the different variables. So that's part one. That's part one. So you don't need to include this title, right? So first, I'm doing the lecture, so I put the part one, and the part two. So that's part two. Objective function. Right, and we use a different color, maybe it's blue. So that's part two. That's part two. And we got a third part. So that's part three. So that's constraints. And this time I don't highlight. So basically for any linear programming problems, you can always formulate the module. Right, starting with identify the different variables, find the formula to construct your object function, and also construct your constraints. So okay, so back to let's put the module into Excel. Okay, so now we're using the Excel language. Basically that's Excel language. That's Excel language because Excel will be able to to calculate. So that's the Excel language. We put the model into the Excel, and we also, so one more step, add the information into the solver. So this part, is also, it's not difficult, but it's also important. So basically, we're gonna go to the solver. Right. So basically, the solver will ask you for three inputs. What's your object function? What the change variables? What's the constraint? Right. So we just put all the information into the solver. So object function, so B8. Right. Remember, we put the formula into B8. So B8, that's our object function. And in this problem, we want to maximize the profit. So we put, maximize. Or for a cost object function, we want to minimize cost. But in this problem, we want to maximize the profit. By changing the variables, so changing variables B2 to B5. And for the constraints, we got the first constraint is greater or equal to 0. And for the second constraint, that's less than or equal to 0. And the third constraint, less than or equal to 5,000. The first constraint, less than or equal to 4,000. And the fifth constraint is less than or equal to 16,000. And we got this, last constraint. So solver provides the, very convenient choice. So you can check to make all the unconstrained variables non-negative. So you can simply do that by checking this. And one more step. So select a solving method. So it depends on the problem type. So if you've got a nonlinear formula, a nonlinear equation, either in your object function or in the constraints, you should choose nonlinear. Or you found all the formulas, no matter in the constraint or no matter in the object functions, they have a linear relation. You should choose simplex LP, so linear programming. Or in some cases, so evolutionary. If your problem are non-smooth, but I think we're gonna discuss that part in lecture 6 and 7, so we skip that part for now. So basically choose simplex LP and click on solve. So solver found a solution. And in case you need the answer report, you need a sensitivity limit report, you choose that. But in this case, we don't need that information, so we choose OK. All right. And you found that so all the formulas have changed to a certain value. So basically means we have solved this problem, and our optimality tells us we should produce 5,458 jars of applesauce. So 12,735 of bottles of apple juice. We should spend $152 on advertising of apple juice and $1,747 spend on advertisement of apple juice. All right, so that's the answer, and which will give us a profit of 40,201. And you just need to put that information into your answer. So basically that's the a complete and a general and solving procedures for a linear programming problem. So hopefully you can gain some new understanding of the LP problem. It's not difficult, it's very essential in order to learn the integer programming and the nonlinear programming. So but they follow the same when we construct a model, that's the principles we need to follow. Okay, so the reason I recorded this video is because some students may like to review the lectures, and also so with the asynchronous video you can pause when you found it difficult or it's hard to follow, and you can review that. So that's all. So if you still have trouble doing these 3 steps, establish the module, put into Excel, add into solver. If you still find issues, feel free to email me, or we can discuss in person. Okay, so I'll stop sharing my screen, and thank you for watching.